Hello again from Paul and Dave. This is the second talk in our series Control Systems 101. Talk number 2 is an introduction to the feedback loop and feedback control. We will be looking at a basic concept of the control loop, the concepts of negative and positive feedback, and the standard terminology that control systems engineers use. So I've got this feedback loop here, and it's something that we all use every day, all day. We all use feedback in our daily lives. And the way it works is this, that you start with something you want to achieve. What do I want? And you take some action and it goes into some kind of process, whatever that is. And you end up with a result. The result probably is not actually what you wanted. And so what you do is we observe what we've got, and the observation obviously may have errors in it. In other words, what you observe is not necessarily precisely what you've got. And so I've labelled this, what do I think I have? So what do I think I have will not be the same as what it is that you want. And so you compare the two, and it's the comparison that's important. And the difference between them is the driving force to take some corrective action. So you do something a little bit differently. And you end up with a change. So what have I got now? You observe it again. Oh, whoops, not quite what I wanted. So again, you have what do I think I have, and you compare that with what do I want, and you might use the difference to take a bit of corrective action again. And so we go round and round the loop. This is a feedback loop. Now let us look at this comparison process in a bit more detail. So we'll look at it in mathematical terms. And this comparison is important. So, in fact, in algebraic terms, the driving force, what it is that you want, is a positive, and the negative is a subtraction. So we are, in fact, subtracting what I've called here the consequential force from the driving force, and we get a difference between the two. So the driving force minus the consequences, and we use that to drive the system dynamic behaviour. Now this is called negative feedback. And the word negative does not mean that it's bad. It's unfortunate that we always use the word negative as to have bad connotations, and that's not necessarily correct. In fact, negative feedback is the good stuff. Negative feedback is stabilising. Negative feedback gives us control. It's that negative comparison that gives us the control. And negative feedback is our friend. Now let us look at positive feedback. It's a strange thing, but the way we talk, we think that positive feedback is good, and that in fact in control systems positive feedback is not good, it's the bad guy. So if we make the feedback positive, so if that's positive and that's positive, what happens is that these two add together and it drives it, and then they add together some more and drives it and drives it, and the thing goes absolutely way out of control. What we get is runaway inflation. This is the classic vicious circle, and that's really a better way of describing, I think, the vicious circle. The loop goes rapidly out of control. The loop goes completely unstable. It's positive feedback that gives us stock market crashes. It's positive feedback that gives us worldwide pandemics. We lose control completely, This is the bad guy. There is only one circumstance where positive feedback is useful, and that is that it gives us compound interest. So if you invest some money and leave it gaining interest over years, it grows and it grows and it grows. And it is positive feedback that causes our superannuation funds to keep increasing. But with superannuation funds, because the interest rate can be fairly low, it can be awfully slow. So now let us turn our attention to the terminology used by control systems engineers. These are the words that we use in control systems engineering, and the set point is the name that we give to our desired value, what we want the loop to control at. The control variable is the output of the controller, and it is also called sometimes the manipulated variable because it manipulates an actuator at the start of the process. The measured variable is the output of the system, this one here, and it is what we measure and it is what we really want to achieve. The measuring device, the measuring instrument, measures the measured variable, and the signal we obtain is called the process variable. The controller is subtracting the process variable from the set point to achieve a signal here which we call the deviation, and the deviation is what drives the industrial process. So thank you for listening to talk number 2 in our series Control Systems 101. I hope you will join us again for the rest of the series. The engineers in control are Dr. Paul Wilson and David Clement. You can find out more about us at www.engineersincontrol.com. Unless explicitly stated, all content in this video is original and is copyright 2021 by Dr. Paul Wilson and David Clement. All rights reserved.